Hello everybody, and welcome to the first video of the semester for our college algebra class. Before I start the video, I want to give a little disclaimer because look who's spending time with me today. This is my cat, and this is a disclaimer because she is walking all over my desk, and sometimes she walks on my writing tablet, and I get a brief interruption from that, but I think that she'll just sit calmly with me and let me make the video. Anyway, so to the video. Before I start the video, I want to say that I make these videos the same way that I would teach this material in a class on campus, where I'm teaching and then there's students sitting out in the classroom. Okay, so I do the same stuff. I show you the same thing. I explain it the same way, except for I go into more detail and go a little bit slower on these videos because I don't have a time constraint. Okay, because in our classes on campus, at a certain point, the class is over and everybody gets up and leaves, including me. So I don't have that constraint here. With the videos, you can watch them if you need them. If you don't need them, you don't have to watch them. You can skip around, right? So I can, I have much more freedom on how much material I can fit in any one video because you have the freedom to watch it however suits you. Okay, anyway, so this video, which I title Introduction to Solving Equations, is just that, an introduction to solving equations, but it's not every kind of equation that we'll see throughout the semester or even for this first module of material. It's just a way for me to get started, okay, as you would guess by me calling it Introduction to Solving Equations. Okay, so here's my first example. Do you see this one right here? It says solve the equation 2x plus 1 is equal to 11. Before I do anything with that, I want to say that we could read the equation. I mean, maybe this hasn't occurred to you yet, but if it hasn't, then I think now's a good time. Every equation says something, and I can read this equation in words as 2 times what number, then plus 1 will give you 11. And if you think of it that way, maybe the answer will just occur to you. I mean, can you think of, like, is there a number, like in this case, a fairly simple number that you could multiply by 2, and then if you added 1, you'd end up with 11, okay? It might dawn on you that that number is 5, and yes, it is 5, right? 2 times 5 is 10, plus 1 is 11. So equations and algebra as a whole don't have to be mysterious, okay? Now, I know that everybody has their limit, and even if you could solve this one just by reading the equation and thinking about what it's asking, doesn't mean that you could do that with any equation, all right? So everybody has their limit, but it's still nice to know that you could read in words what an equation says, what any element of algebra says. I think that would make it more relatable and understandable if you were open to that. Okay, anyway, so here's what we do when we solve equations most of the time. We start with the equation we want to solve, and we rearrange it until it looks like this. See, like this, it says x equals, and whatever number you can isolate over here is the answer, okay? Now, I'm not saying every equation is solved like that, but many of them are. So we'll rearrange this, move stuff around until it says x equals, and then we'll have our answer. The way we do that is, well, there are lots of techniques, but we could add the same number to both sides. We could subtract the same number from both sides. We could divide the same number on both sides, or multiply the same number on both sides. Just think of those as your techniques to rearrange this. So, for example, now I am showing you this with it in mind that if you're in this class, it's supposed to be the case that you have at least seen this somewhere before. And I'm just refreshing you at this point, all right? So what I could do is I could subtract 1 from both sides, right? An equation is like a balanced scale. That's what the equal sign represents. And so it's balanced, and if I took 1 pound off of each side, it would still be balanced. The goal is to rearrange it, keeping it balanced the whole time. So if I do that, say I subtract the 1, I get +1 and -1. That makes nothing, so I just get the 2x left over. Maybe you can see how this is rearranging it. It's like that 1 moved over to the other side, okay? And then 11 minus 1 is 10. And then from there, since my technique is generally that I will add, subtract, multiply, or divide the same number on both sides, then I'll divide both sides by 2. And if I do that, I'll get where I want. I'll get to my goal. 2 divided by 2 is 1, okay? And that will leave me with x, or 1x. And then I'll get 5 over here. 10 divided by 2 is 5. And there is my answer, okay? All right. Yes. So final answer in the box. I'm committing to that. You want to know what solved this? I'm saying it's 5, okay? Now, speaking of that, here's something that I've alluded to that I want you to do for at least this first part of our class, so that, we can verify that we're right, okay? If there's any doubt, that's called checking. So I can take 5, this number that I think is the answer, and I can put it in here in the x, and the x is this unknown number that I'm trying to figure out. And I can see what happens. All right, so it's like I get 2 times 5, and then I put +1, and I get 11. And I'm gonna put a question mark above the equal sign just to be dramatic about it. Like, I'm wondering if that's true, okay? And so 2 times 5 is 10, +1. Oh, that says 11 is equal to 11. That's a correct statement. And to solve an equation is to find the numbers that make it true, okay? All right, I'm not saying there was any big mystery about 5 being the answer, because remember when I read the equation to you, I said it sounds like 5's the answer, all right? And 5, sure enough, was it. Okay, now let's try this one. Now this one looks more complex, okay? But I have a similar theme going on with this one. There are people in the world, and there are people that sometimes end up in our class that can solve this one just by thinking about it. It's like, I need to put something in and multiply by 3, subtract 10, and I take the root, and then I get the same number on the other side. So some people, again, just kind of look at it, maybe with a little trial and error, figure out what's it. Okay, that's great if that's you, okay? But for most people needing a technique, here's what we do. Remember, I was saying generally I'll do the same thing on each side to keep it balanced, okay? And here the difficulty is this root. Like, that stuff in there, 10 minus 3x, is stuck in there. I can't move it out of there and, let's say, put things over on the other side if I wanted to. It's just stuck in there, okay? All right, so here's what I do. That root is, it's like holding everything inside it where it is. And if I could get rid of it, then I could move things around freely. Okay, so what I'll do is I'll square both sides, okay? So again, I'm keeping the equation balanced. I'm treating each side the same. I'm doing the same thing to each side, but that thing is that I'm squaring it, okay? All right, so if I do that, then the square cancels the square root. They're opposites, inverses of each other. It's kind of like adding 1 is the opposite of subtracting 1. It gets you to nothing. And multiplying by 2 and dividing by 2 cancel each other out also. Get you back where you started, get you to 1, okay? All right. So here it's the square root and the second power are like that. They're inverses, opposites of each other. And so here's what I get. I just get 10 minus 3x on the left, and then I get x squared on the right. Okay. Now, to solve this equation, I won't be able to rearrange it to get the x by itself. All right. Okay, I said generally, yes, that's what you do, but here, like, that won't work. Okay. So here's the technique. Suppose that the way I was treating this one, move everything to the other side. Okay. So let's see, and I'll just have to ask you to bear with me in order to see why this is going to work. So I'm going to subtract 10 from both sides, and that will move the 10 over. And I'm going to add 3x to both sides, and that will move the 3x over. Okay, and I'll show you why that ends up working once we get to the end. Okay, all right, so everything cancels and gets me to 0 here. And then with the stuff left over, I can't combine any of it. None of this stuff is compatible to be added. I can't add x squared to 3x, and I can't add either of those things to 10. In algebra, you can only add like terms. You can only add things that are like each other. You can say, like, if I had 4x squares and I add 2 more x squares, that would make 6x squared. Like, that's the kind of stuff that you can add together. Those are called like terms. It's the analogy in algebra is it's adding apples and apples. 4 apples plus 2 apples. Okay? You can't add an x squared and an x because that's like apples and oranges. Like, what would you say 4 apples plus 2 oranges was? 6 pieces of fruit. But you can't say it's 6 apples and you can't say 6 oranges. So we just leave this kind of stuff. Okay? Can't add it. Can't combine it into one thing. So look, we get x squared plus 3x minus 10. Okay. At this point, what we'll do is we'll factor it. Okay. All right. So, okay, let's see. Factoring. In this case, I have another video that I'm linking with the rest of the videos about factoring. But for this one, let me say that the technique for factoring is to think of two numbers that add to positive 3 but multiply to negative 10, and then fill in this template, because the way you would factor x squared plus 3x minus 10 is x plus some number times x plus some other number. Now, those numbers that I'm leaving blank at this point are the two numbers that would add to 3, positive 3, but multiply to negative 10. So that's going to be plus 5 and minus 2. That's what you multiply together to get x squared plus 3x minus 10. Okay? All right, so I factored it, and then here's what happens. Okay? Remember, I said you'll have to bear with me a little bit for me to show you why I was doing it this way. What this says is this thing here, x plus 5, times this thing here equals 0. Okay, but in arithmetic, what's the only way to multiply things together and get 0? The only way to multiply two things together and get 0 is to multiply by 0. So if this thing here, x plus 5, times this thing here, x minus 2, is 0, then either x plus 5 has to be 0 or x minus 2 has to be 0. Okay? And I guess that's what gets me to my goal, isolating the x. Like, so this one says x is equal to negative 5 is an answer, and this one says x is equal to 2 is an answer. So I get these supposed answers. I get negative 5 and 2. Okay? All right. So that's how we can solve this one. Now, I understand that we're just getting started. Some people have some gaps in their knowledge. You might not understand the factoring step, but I got another video on factoring, or you might see that as something that you'll have to ask about or learn a little bit more about. But like, my point is, even if there's some of the steps you're not so sure about, this is a series of steps that will get us an answer to this type of equation. So if you're doing your assignment and you see something that says root something plus x equals x, then like, here's the technique that we can apply to that. Okay. Now, remember back on this one, I checked it, okay? And I said, well, we can do that if there's any doubt. And here with this one, we might think that, well, it looks like we did everything right, okay? I don't feel like I made any mistakes, and I can double check all my work to verify that I didn't make any mistakes, all right? But there's like something weird about this type of problem where even if I do everything right, it doesn't mean both of these answers are guaranteed to work, okay? All right, I mean, it might happen that neither of them work despite the fact that I didn't make any mistakes. Or that maybe one or the other doesn't work, despite the fact that I didn't make any mistakes. Or it might be that both of them work, okay? Okay, all right, so I have to check this one, is what I'm saying. That one of these answers might not actually work once you try it. And the whole point is to find a number that when you plug it in to the original equation makes it true. I can't guarantee that about these without checking it. Now, when the general rule is whenever you square both sides of an equation, whenever that is one of your techniques that you use, you have to check it. Okay, so let me say that I must check it. It's not optional at this point because I can't guarantee both of those work. Let's try the -5 first. Okay, so I'm gonna, what would checking that amount to? I'll plug it in, see what happens. Okay, so 10 minus 3, and then I put that -5 in there as the supposed answer. Wherever I see an X and I put a question mark above the equal sign just to be dramatic about it, just to tell you that I'm wondering if this is true, trying to determine if this is actually correct. So here I get 15 positive and 10, so that makes 25, okay, and -5. So still a question mark. Is that true? Is the square root of 25 -5? Square roots are so defined that they are only positive. So the square root of 25 is 5. Okay, it's not -5. And if you don't believe me, get your calculator, which I recommend that you get at least a scientific calculator if you're learning algebra, if not more, but at least something like this. Do root 25, and it tells you it's 5, not -5. So this just isn't correct. It's just not true that the square root of 25 is -5. Okay? All right, and so that one doesn't work. Oh, so like I was saying, like I couldn't guarantee they both worked. Like I thought a wrong answer may have just showed up despite our best effort. Let's try the 2 now. So I'll plug 2 in, and it might be that that one doesn't work either. Okay, so let's see. 10 minus 3 times 2 and equals 2, and I'm again being dramatic. I'm putting the question mark. Is this true? And this says 10 minus 6, so that would be 4. 2. Root 4 is 2. And yes, the square root of 4 is 2. Okay, so check. That one did work. This is what I was looking for from the beginning, was that a number that when you plugged it in worked. Okay, all right, so 2 works. It produces a true statement, not a false statement. This 5 equals -5, not true. 2 equals 2 is true. So my solution is that x is equal to 2. That's my final answer. And the box is always where I put the final answer. That's what I'm committing to. Not what's down here, right? I'm checked that and committed to this. All right. Okay, so that's how we can solve an equation that looks like I had this one in its initial form. Let's look at one more type, okay? All right. So this one has a fractional exponent. All right, it says x to the power 5 over 2 is 32. And a fractional exponent is kind of a strange thing because, I mean, like a whole number exponent, that's pretty easy. Like 2 to the 3rd power means 2 times, you multiply 2 by itself 3 times, okay? So 2 times 2 times 2, and then you'll get 8. So that's what a whole number exponent means, but a fractional exponent. That means something like this. Okay, now I thought I'll explain this more in a minute. Okay, but how about this? Let's start with the method. How do you solve something like this? I'll give you a method for all these problems. For one that looks like this, we square both sides, then we move everything to one side with 0 on the other, then we factor, and from the factors we get our answers. Okay, for this one, what we do is this. I will raise both sides to the power that is the reciprocal of this fractional power that you see. So I will raise both sides to the power 2 over 5. Okay? Why would you do that? All right, well, so remember that when we rearrange an equation, like if I want that 1 to go away, I subtract the 1. Okay, and if I want that 2 to go away, I divide the 2. So here it's kind of the same thing. It's like I want that fractional power to go away, because if I could take it away, I would have the x by itself and it would reveal my answer. Okay. So anyway, so say I do that. Why does that work? Well, we might need to review some things over the course of the semester. Okay. And one of those things is the rules of exponents. So let me mention something real quick. So as far as rules of exponents, if you take a number, so look at this, here's how I'm reading this. If you take a number and you raise it to a power, and then you raise that answer to a subsequent power, you can also just multiply the exponent. So x to the power 2, then to the power 3 is x to the power 6. Multiply the exponents in that case. When you multiply two like things, x squared times x to the third power, then you add the exponents. And when you divide like things, x to the third power over x squared, then you subtract the exponents. Okay, so the reason that I'm taking both sides to the reciprocal power here is because then I would be called on to multiply the exponents together. So here I would be called on to, I get this, multiply the exponents together. It would say the power is x, or the result is x to the power 5 over 2 times 2 over 5. Okay? And then over here I get 32 to the power 2 over 5. Now what's the power here on the x? Well, what's 5 over 2 times 2 over 5? Because you're supposed to multiply the exponents in this case. That would be, well, then we'd have to review fractions. But you multiply fractions straight across. 5 over 2 times 2 over 5 is 10 over 10, which is 1. So that's a 1. That's why we take both sides to the reciprocal power, because it calls us to multiply the exponents, and it turns out we get 1. All right, so we'll get x here, and then our answer is 32 to the 2/5 power. All right, now for this, to figure out what that is, to figure out what our final answer is, here I'm telling you the answer is 32 to the power 2 over 5, whatever that is. You'd have to tell me whatever that is. Now, you can, of course, use a calculator. I have a basic scientific calculator right here, and I can compute that if needed. Okay? I don't give advice on calculators in the videos because people have different kinds of calculators, and I find that I can't say something that is applicable to everybody. So if you have trouble with your calculator, you can ask me about it. All right, so I'm going to say that you can do this last step with a calculator. All right, an online calculator or a handheld calculator. Ask for help if needed, but I think that if we're going to do math in an academic way in school, then we should really learn how stuff works. All right, so let me tell you how you can calculate this without a calculator. Fractional exponents have this interpretation. If I have some number x to the power a over b, b is the root on the x and a is the power. And it doesn't matter what order you apply those. So here I can do the a power on the x first and then the b root, or I can do the b root on the x and then the a power. Either order, it does not matter. So if I have 32 to the power 2 over 5, that means the 5th root of 32, then raised to the 2nd power. All right? I think it'd be easier to do it that way. I mean, I could do it this other way. The 5th root of 32 squared, right? Because I said either order was okay. But I think, like, at least for me, in my head, it'd be harder to do 32 squared and then take the 5th root of that. So I'll do it like this. So 5th root of 32. What do I multiply times itself 5 times to get 32? That'd be 2. Okay? And then I square that, and then that will be 4. So 4 is my answer. Final answer. Okay. I could check this one, but as long as I did everything right, I don't have to. All right, in this one, whenever we square both sides, false answers could show up. You have to check to rule them out. And this one, as long as you do everything right, that answer is going to be correct. And I've done everything right. I'm not worried about checking it, but you can if you want to. All right. Let's try something similar on this one, okay? So here's one that kind of looks like the one that we're just doing, but has like an extra number in it. So let's see. I don't know. How about this? So I'm looking at something, like I said, a lot like the last one. It says x minus 3 to the power of 5 over 2 is 32. Okay? And you could, how about this? I think that there are some people that are inclined to move that 3. So remember in that first problem that I showed you, and I said, I want to rearrange this to get the x by itself. So if I can move that 1 over to the other side and then move the 2 over to the other side, I get the x by itself. It reveals my answer. And so I feel like some people are inclined to do this. Say, oh, that minus 3, I need to put it on the other side. It would be like this other equation if I did that. So like plus 3 on one side, plus 3 on the other side. Oh, and then you get the x, and I guess this 5 over 2 is left behind, and then it's like 35, and so on. Well, you can't do that. That's wrong. You can try to do it this way, but you'll find that you don't get the right answer. Bottom line. Okay, so it doesn't work. Bottom line. As sensible as this seems, it doesn't work. Okay? Algebra doesn't really always match up with common sense. It might seem sensible to do this, but it doesn't work. The reason is that this exponent is holding in the 3. So until you get rid of this exponent, that 3 is stuck in there. You cannot move it. You cannot add anything to it from the outside. It's stuck. So we cannot do what I just showed you. What we can do is treat it exactly like this last one and deal with the power first, right? So if I take both sides of this and I raise it to a reciprocal power, okay, then I get some canceling. All right, because what do? If I take a number and raise it to a power and then a subsequent power, I multiply them together, and the power will be 10 over 10, which is 1. So let's just say at this point that they just cancel, and you'll get x minus 3. If you want, you can say you'll get x minus 3 to the first power, if that will be more consistent. But that x plus 3 to the first power is just, x minus 3, I misspoke. X minus 3 to the first power is just x minus 3. Okay, so now we're here. So we can do two things at this point. We could either add 3 to both sides and figure out what that number is, or I can go ahead and calculate 32 to the 2/5 power if I'd rather do it that way. Okay, now remember, you can use your calculator to do that if you want to. You could work that out by hand if you want to, but 32 to the 2/5 power, as we have calculated it before, is 4, however you do it. So let's say that you get x minus 3 equal to 4. That's what this number is. And then I will add 3 to both sides in order to completely isolate the x and reveal my final answer of 7. Okay. All right, and then I'm done. I don't have to check this kind, as so long as I have been careful with all my steps and I haven't made any mistakes along the way, then I know that 7 is the right answer. Okay, so let's see. Let's do this. Now, one last disclaimer now that I've gone through everything that I want to go through. Of course, you can take your time doing these like I have. I've taken my time. I've explained some things on the margin a little bit. I've reviewed some things. I'm not saying that you have to, of course, take as long as I do to do it. You can, once you learn the steps and once you know what to expect, go through it very quickly if you want to in just 2 or 3 steps. All right, that's fine. But this is what you will see in the videos, hopefully. Slow and thorough explanation, some reviewing, some explanations in the margins of related things, okay? But I'll leave it to you to take that wherever you need it.